We're ready to start the next session. So, quick introduction to your speaker. Aleksander started programming by copying basic programs, and that was nearly 20 years ago, into his Commodore 64. Since then, he's been working in startups, research institutes, consultancies, and post-agile product companies. Emphasis his, not mine. His journey towards closure started with Structure and Interpretation of Computer Programs, which is an amazing book. He joined ThoughtWorks after that, and he caught the closure bug, and he's been a fan ever since. Although he retains a healthy dose of respect for the usefulness of good type systems. So talk to him about type systems. Over to you, Alex.
Hi everyone. Welcome to my talk. This is a cute puppy. My talk will be slightly different from the previous one. It won't be code-centric. I actually don't have any code in my slides. And I'd like to talk more about ideas and where do we take them. I think I need to stay away from this part. I want to talk to you about functional programming in general, about systems architecture, and how ideas from one can influence another. And in particular, I will be talking about experiences from the system I've been working on for the last 2 years in my current company where I work now. And also I will be interested in hearing about your experiences, possibly. So if at any time you think like you have a good question to ask during the talk, maybe you don't understand anything, maybe you want to contribute your own point of view, please raise a hand. I will try to accommodate you and let you speak during the talk as well. So, to me, it seems that as software developers, in particular, maybe as humans in general, we tend to reinvent the same ideas again and again and again, in different contexts, in different times, in different communities, in different languages. It seems that when a context changes, you move from one to another, we forget almost everything we've learned in the previous one, and we laboriously start learning the same thing from almost scratch. My favorite example here are shadow languages in external DSLs. If you use something like Ansible, you might have noticed that they have 10 different iteration methods, each iterating over different type of resource or thing. There's no abstraction, general abstraction over iteration. There is again and again, like iterate over this particular type of resource. And I will say a bit dramatically, time to stop it. This talk is about getting ideas from one context into another and trying to learn across the context. And in particular, I will be talking, as you might have guessed from the title, about taking the ideas from the functional programming and reusing them when designing the architecture of the systems. We talk about programming in the small and programming in the large. Programming in the small is about programming single system. Programming in the large is designing the whole system of the that we care about. So we will talk about how we used at USwitch, where I currently work, the ideas coming from loosely defined functional programming and how we've applied them to redesign and re-architecture our systems. So Mohit gave me away a bit. I came here for this talk from London, but just like a small side remark, I've lived in Pune before. This is me hiking around Pune as a proof, and it's a great pleasure to be back here to give this talk. I work at USwitch, which is a price comparison site in the UK. We do compare things like energy providers, broadband providers, insurance providers. In the UK, at least, it's a highly competitive market, and at any point you can decide to switch between your energy provider. Also a very confusing one, because the providers try to make it more difficult to understand what's really going on, and therefore a website like USwitch is useful for them. And USwitch is also one of the longest users of Clojure in the UK. We've started around 2011 and haven't looked back since then. You may say, like, across the company we have multiple languages, technologies, approaches, but still Clojure and ClojureScript are the default tools of, the tools of choice when we start a new piece of work. So enough of the background, enough of the boring stuff. Let me tell you a story, which is also a problem statement that we will try to solve during this talk. I joined the company. So, okay, this is USwitch around 2011. The part of the company that I've joined was acquired as an external company by USwitch around then. And when I've joined at the end of the 2014, the original systems were still in place. They were written in a true startup style. Let's get something out as quickly as possible using the technology we know and love, which for the original developers was PHP. So they had this lovely PHP monolith, both used for managing the whole site, all the products, the broadband providers, and it was also serving the pages to the customers. And this lovely system was, like the management system, was nicknamed Backstage. We will be talking more about, mentioning Backstage a bit more, so that's why I mentioned the name. At this point, meet Tom. Tom is the content editor. That might be not the real picture of Tom. But there was a person like Tom in the team, and all the issues that I describe here were the real issues at the time. So Tom is responsible for making updates to the system. The tiny issue is that the Backstage, the management system for our products, doesn't have a concept of promotions, which are an important way of how providers in the UK sell their broadband. They might tell you that sign up for this deal right now, we will get you £100, or discount the price for 1 month by 50% so that they can advertise on their websites the smaller price instead of the huge increased one after the initial period. Backstage also doesn't have a concept of scheduling, scheduling changes. That means that whenever a new product or new promotions comes into place, Tom needs to be at their computer whenever the change happens. That means Tom, instead of going to the parties on Sunday night, needs to sit at their computer, laboriously updating each of the pages that mention the particular product, because that's what when the change happens. And the result? It's not only grumpy Tom, obviously that as well, but at midnight on Sunday you don't always remember to update all the pages you're required to update. There are discrepancies among the pages. There are confused customers. There are compliance issues. On top of that, a lot of data we had was actually represented purely as content, as text in the page. So for example, when there was a promotion, £100 voucher, it would be represented as a piece of text that Tom would enter at the page at the time. That was not good enough. We wanted to analyze the data and provide helpful support for the providers so they can update their pricing strategies. And this was also the time when CMA, okay, there was an issue with the slide, the UK governmental agency supervising the competition and championing customer rights, started getting interested in price comparison website. There were some issues that customers not understanding what they're buying, not getting the best deals. CMA steps in and says, okay, we will check you. So let's recap what issues we've had. No concept of a deal or a promotion in the system. No scheduling of changes. No means to analyze the history. Increasing compliance risk. Also, the old system was a single place where all the complexity and scaling requirements were centered. They were not spread out. And at the same time, there was also appetite for rebranding, making the pages look nice. We were in trouble. We needed a new system that would solve our issues and be prepared for any new challenges ahead. We couldn't stop the business for the duration of the projects. We needed to move fast. We had some good start though. We had a good, closely knitted team. All the involved parties were in the single place. And we had the support of management that understood the problem, how important was it to solve it. So, at this moment, what next? What do you do at this particular moment? Who do you gonna call? Ghostbusters? Or Rich Hickey? So in our case, we decided, like, we've got the team together and started in brainstorming and designing. I think like a lot of the ideas that we came up when which drove the design of the new updated systems were actually inspired by the thought of Rich Hickey. He, across his career, across the, like starting from 2009, Rich gave a lot of interesting talks, and if you're interested in closure, I'm sure that most of you have watched at least few of those. If you haven't, do it right after the conference. But the thing is that Rich, in his talks, mostly talks about programming in the small. Like how to design a particular singular piece of software. So the thing we did was to take those ideas and apply them to a certain degree when designing the system. And you can't say it's like one-to-one translation, because obviously they are not the same. You can't say that like the functional programming ideas drove or were implemented in the system, because again, they are like slightly different contexts. But at least for me, there was a close connection between those two. So this is what really got me excited, and this is what inspired this talk. So yeah, at this point, like, I wanted to maybe ask you if anyone wanted to tell, if you were starting a project like this, like, how would you start, and where would you find like, inspiration? Like, where would you start designing ideas? Okay, we can also always talk about it after the presentation. I will present the ideas we came up with. So these are the 5 that I wanted to talk about today. These are the explicit concept of time, immutability, data function separation, memoization / pre-computing, and complexity separation. I will present those ideas as like as they appeared magically in our hands. Day one, let's design the system. This is how it's gonna look like. That's not the case. This is the result of like the weeks of discussions, weeks of spikes, some refactoring, some updates to the system. But yeah, let's start. So you've heard the problem statement. We needed a new system. We wanted to rebuild the system, like move to the new word while keeping the old the page running. There was no chance of like simply taking the the new system and making a big bang release. The business risk would be too large, and the management would never allow it. And in the old world, the backstage, the management system of the products, owned all the data. It was a PHP system sitting on top of the database. You wouldn't be able and there was also a decision that this is a legacy system. We don't want to make updates to it. it's not that we want to refactor the existing system. This is the technology we don't want to work with anymore. Let's move on. So how do you make the data that is owned and then closed with one system available to the new world? The approach we've chosen was to create a new deal management system that would have the concepts of deals, products, and promotions, and move to it gradually, starting from one product, then one provider, then some more pages, and so on. We still needed to share the information between the two of those. So we decided to start publishing the changes for the deals to outside world, to the timeline. Whenever a deal changed, the broadband deal system, the name we've chosen for the new system, would make it public that a new deal is available for the others to consume or act upon. So I've made a simple diagram of the new system. This is like a simplified version. I will be flipping back and forth a bit between those two. So here, let me check if, yeah, here. No. Okay, it seems that the pointer is not really visible. Okay, so this is the system the new system that manages the product and publishes the events to the outside world. And the requirements that we had was to have that each of the products can be acted upon by multiple consumers, by multiple other systems, so we can do more with it. We wanted to have the ordered stream of deal states in the new world. And this was our model of time. So whenever a new fact appeared, a new event appeared in our system, it would be published to Kafka or Kinesis. Actually, across the time we used both, so that other systems can consume it. And that led us to have a number of product states that can get backported to the Backstage database so that we can keep in sync the two words. Am I convincing here? Because I know that this is probably the biggest, at least the stretch that I'm making in this presentation, so I wanted to make sure at least some of you are partially convinced that the stream of events published to the public timeline can be a model of time. This is definitely how I was thinking about the system when I was designing it and talking about it with my colleagues. So maybe let's talk about the events themselves now and what are the key features of the events. the time is probably one of the very few topics about which you can discuss more than functional programming. You can have endless conversations about the time, different understanding. For this system, for this model, we've chosen the discrete ordered events getting published to the public timeline. So you have a number of events that the other systems can act upon and process them. The key features of those events is that there are values. They're immutable. When you think about it, each event, once it happens, it cannot change. The fact that this talk by Aleksander Sumowskl started in this place at 9:45 won't change at any point of the universe, of this universe at least, ever after. If I give the same talk at different conference, it will be a separate event. If someone else were to give the same talk at other place, the same content, it would be a different talk. So what does this let us do? Like the fact that each of the events published to the timeline, to the published timeline, is immutable, means that each of the systems that act upon those events has certainty that it can process the event only once and be done with it. There's no way that someone at the later time, like 2 weeks later, someone like a wizard, like a traveler in time, comes back to the system and changes a feature. Okay, this talk actually started at 10:45. No. This talk started at 9:45, and nothing in the universe will change it. So you can have independent systems acting upon the public events with no need of coordination, no need of holding any reference to the events. And also, at this point, behold, look, the data is actually the central point of the whole system. The stream of changing value, of values, is what is central to the system. And you can have multiple functions, multiple other systems acting upon the values that get published to the public timeline, which is an important feature of the functional programming. You do separate the data and the functions that act upon those data. And finally, another nice, interesting feature of the system was that we have the one. Okay, I will just finish this one and then let you. We have one-way data flow in our system. The initial, like this, we have the single source of truth in the system, the deals admin, and all the consuming system, the systems that act upon, create their own aggregations or transformations of the deals and other external external data. But we ended up pre-computing almost all the data required to run the website. At the end of the day, the broadband web ended up a static HTML and JavaScript page that would load the information about the tables and the products and the deals from a S3 bucket from AWS. Because all the data that we needed was coming from the deal system one way. Okay, there was actually someone. Hi.
Just want to understand your concept of public timeline and what is the tick of your timeline? Who controls the tick? Because it has to be some sort of a granular, where you say this event has happened after this event, and hence a concept of a tick. It cannot be gradual. So how did you manage that?
Yeah, so in this concept of time, basically the future is a pure function of the past. You have the one tick, which is the current state of the system with the deals and tables, and the tick is a new deal arriving in the system. At this point, we take the new deal, check wherever it appears in the tables that we present to the customers, and update, generate all the data for those data, making it a new word like that. Is it answering your question at any time?
So if you have two different systems and two different deals arrive, you still have this problem like which came first and which came after. So some sort of a.
So I think I've mentioned it, but maybe not strongly enough. One of the things that Kafka or Kinesis provide you is the ordering, or the total ordering. Each of the in the particular topic or stream, each of the systems acting upon the values from the system, from the stream, will receive the values at particular time. So that's why there is no need to coordinate them as well. Where were I? And yeah, finally, this means like the final feature that I've mentioned was the complexity separation. This actually doesn't fit that nicely into the theme of ideas inspired by functional programming. At least this is not what you would say a core feature or of functional programming, or the feature that is specific to functional programming. But it is a good way to design systems anyway. So I thought that I will include it because this is one thing that I really liked about the system. So all the complexity that we had in our system was almost exclusively centered around the deals admin. This is where almost all the calculations happened. Later on, all the systems that acted upon the deals were just doing really simple data transformation, like making it more easily consumed to the end website. And that's it. This is like another maybe timeline that I wanted to include as well. I will talk it over a bit quicker, but this is a timeline of the sales happening in our system. In this case, we didn't control the whole transaction. We wouldn't know exactly which clients would buy the broadband or not, finish the transaction, because what we were doing was redirecting them to the provider web pages in the end, and they would transact there. We would get the information about the transactions from affiliate networks, which would tell us, okay, the client with this identity, with this click and ID, bought or haven't bought the product. So we were, and they would publish this information usually as XML or like some kind of data format. We would need to poll it. And this is also the way that another like divisions of the company work as well. They would operate in the similar way, but they would need to poll the same affiliate networks. So what we did was to create a single system that would poll the affiliate networks and publish all the information about the sales to Kafka. And for the purpose of my team, the one that I was working on, it would filter the sales and publish to another timeline only the broadband sales. And then we wanted to enrich the information coming from the affiliate networks with the information we stored about the sales ourselves. So we did the enriching of the data. And eventually, we would push to Redshift and BigQuery, which are respectively Amazon's and Google's systems for big data, so that our analysts can work out the patterns and do their magic. I presented a really nice, it says 10 here. Okay. I presented this story like as everything happened nicely, there was a nice model, no issues. That's not true. Like that, there are issues and caveats with each approach. I think that one of the big issues was the data shape across the services or the functions. We had multiple microservices and AWS Lambdas processing the same deal. Sometimes it was difficult to work out what was the exact shape of the data coming into your service. We should have used closure spec or schema at the time more. That's something we didn't do. You should have done it. Like if you're developing any kind of distributed system, do so. The distribution part, again, whenever you're entering distributed word, it turns out that here be dragons. It's more complex than you thought. It's not that easy. The one thing that I didn't realize when starting this, like using this approach, the conceptual model of Kafka or Kinesis are really simple, but those systems, they guarantee you the ordering of the events. They guarantee you at least once delivery. So this is the caveat. You need to be able to handle more than once delivery. And there are like way more actually the issues with working with such systems. If you're interested in this topic, like you can either talk with me after the presentation, and there is a really nice presentation about working with those systems and on this year's Strange Loop. I recommend it. It has some really nice patterns explained how to work with Kafka or Kinesis. And the end result of what we did wasn't polished. Again, the image that I'm presenting to you is like nice, everything works, we are happy. We are happy with the end result. It wasn't polished. There are still parts that use mutability. There are still parts that use the old backstage system. There are still parts that sometimes fail. At least for us, the key thing was that they will never be polished. The development we have, like the approach to development, is that it's really closely aligned to business. The priorities change. We do the things that are most important to the business, and then move on. This is the result of our redesign, which is nice. Now you can see that after the release of the new model, with the promotions, deals, all the information available to the end site, we can do the filtering, sorting, and all the information, the nice features that clients wanted. We can do the comparison of the particular offers, which a feature that wasn't possible to do in the old world because the data models weren't rich enough. So, key takeaways that I would like you to take from this presentation is when thinking about the architecture of your system, when designing your software, don't limit yourself only to the pro art in the particular area. Also look around. There might be some inspiring thought or inspiring ideas in the world around. Grow architectures. If you have the possibility, it's possible, this is actually the first project that I personally have seen it happen, but it's possible to refactor the whole system if you give it appropriate attention and time and turn their love. And learn from mistakes, ideally of other people, maybe attending conference like this one and talking with the speakers during and after the presentation. So yeah, that's actually the content that I had for you. Any questions? Thank you. Okay. I already presented nice puppy again, but yeah, I can take the. Okay, so yeah, that's the bit that.
Alex, can you repeat the question for everyone?
Okay, so from what I've heard, that the question was that a lot of concepts that I was talking about are well represented into Datomic, and why did we go with the Redshift? Okay, this is the bit that, obviously I recommend researching and inspiring. I don't know Datomic to the extent to be able to tell you. Can you have a stream of events with multiple systems having a pointer to the point of time and tracking the versions of the event or versions of the multiple events across the timeline in Datomic? Mm-hmm. I think the simple question to this answer is that the Kafka was already used in the company, and it was meeting all our requirements. We didn't use Datomic. So you don't have always to come up with new solutions. If there is something you already have in the company in your system that works and meets all your requirements, I would recommend using it.
Any other questions? Just an interesting observation that Rich Hickey has a video called The Language of the System, which is pretty similar.
Okay.
Like he's taking ideas and extrapolating them out to systems. So that's worth a watch if you're interested in that sort of thing. Thank you so much, Alex, for coming down from London and battling your jet lag. Please give him a big round of applause, guys.
Thanks.